In this video, I'm going to focus in on part 2 of the Country Profile 1. We'll start off with our initial startup, and once again, this is a friendly reminder that when we begin here on this first screen, go to the Enterprise login, and this is once you click on that link. And so once again, you're going to click on Indiana University and then do your typical song and dance, and you're now signed into ArcGIS Online, which once again you've been given free access to because of you being a student at IUPUI. So we go back to our map. So I'm going to go ahead and search for our countries, and so let's go ahead and look at Japan. So that's our country, and what we're going to do is we're going to look at temperature. So here we have mean January land temperature, and then if I click off that and then click on here, I have mean July temperature. And so what we can do is we can compare essentially the two opposite times of year, January and July. And if we look at Japan, we don't see much difference. And it's always useful to zoom out and kind of see how your country, this is once again why we have two countries which we're analyzing, just because it's useful to compare and contrast them. And it's going to look between these two different layers. And you'll notice that, wow, Japan, it pretty much is the same color both in January and July. There is some differences, but for the most part, it's the same. Now, if I go ahead and I look at Mongolia, I got Mongolia, and you can see Mongolia, all of it blue for the most part. Then come the July map, and now we have a lot more reds and blues. So there's a lot more variety in the seasons here in terms of the temperature. And so the January, quite cool in Mongolia, and the July, it varies. I mean, it's cool in parts, but it's not the same pattern that we saw beforehand. So this is the kind of stuff we're looking at. Once again, blue we associate with colder temperatures, and then red and oranges we associate with warmer temperatures. So some things we can start doing. Of course, we can start off talking about latitude. We can talk about the role of latitude. And of course, when we compare our two countries, one of them is closer to the equator. And so Japan here, being located closer to the equator and closer to the Tropic of Cancer here in the northern hemisphere, compared to Mongolia, you're going to see warmer temperatures. And that's the case in both January, but also in July. And so here it's consistently red and oranges. And so we can compare the two and say, on average, temperatures are warmer in Japan, especially there in the southern part of Japan. And that's very much characteristic of latitude. And so with latitude, why is Japan warmer? Why does it have warmer temperatures? Well, it's first off closer to the equator. And what that means is it has consistently higher sun angles. And once again, higher the sun angle, the more intense the sun's rays are. And so it has a higher sun angle consistently throughout the year, but it also has a more consistent day length. So you're not going to have the situation you might have in the more polar areas and more northern areas where we have one time of the year in which you got just a few hours of daylight, and then another time of the year where you have 20, 24 hours of daylight. So that's something when we look at latitude, we can say as you go south in Japan, temperatures do get warmer. And that definitely corresponds to latitude. And we see that also play out in Mongolia as well. And that's definitely more noticeable there in the case of the July map for Mongolia. Now let's talk about altitude. And so altitude, we should be able to see altitude quite clearly. So once again, as you go up, temperature goes down. And so just by looking at this Mongolia map, just by looking at this map of July temperature, once again, January not shown here. So July temperature, just by looking at this, we can see blue areas. And those blue areas, once again, what do they correspond to? They correspond to these rugged areas. And so you can see elevation. And so something I would do is I would want to zoom in here and maybe do some research, just do a Wikipedia search and find out what would be the mountain range through here. What is this rugged feature that comes through here that causes higher elevations and then subsequently cooler temperatures? Once again, as you go up, temperature goes down. And so you can see in these lower lying areas, the temperatures are warmer. But once again, let me guess, this probably corresponds to a plateau or an upland area. And if I click off that, yep, most certainly it does. So you're going to see evidence, hopefully, unless your country is the flattest country in the world, you're going to see evidence of of altitude playing a role in temperature patterns. And so as you go up, temperature goes down. Let's see if we can go into Mount Fuji here. I'm trying to remind myself where Mount Fuji is, somewhere in this area. But anyway, so it's obviously quite rugged through here. Let's see if we see a pattern. Will we see cooler temperatures up in this particular area? And as we get in this particular area where we see Tokyo, temperatures are going to be warmer. And that's most certainly the case. And so you can see those upland areas. And so those upland high elevation areas where temperature is cooler, both in July, but also in January. We can see a little bit cooler there, those yellowish colors. And so now in the case of Japan compared to Mongolia, you don't see as far as a huge swing in temperature patterns, but nonetheless, you do see evidence of altitude. And so what I would do is if I were you, if I had Japan as a country, there it is. You can see Fuji there on the climate map actually stand out quite clearly. This is Mount Fuji. And so if I just, come on, temperature. Then you can see right there is Mount Fuji. Kind of cool. And so you can see specific rugged features. You can see them play themselves out actually on a temperature map, something that has nothing to do with elevation. Next up is land-water heating differences. In land-water heating differences, what we're going to be focusing in is your country, or your country for the most part continental. What that means is it deep within the continent, or is it far from a large water body? Maritime are places that are along a coastline. Maritime are places in which they're near a large water body. And so, of course, Japan, compared to Mongolia, I've got great examples of one being in a continental, one being essentially landlocked, and then the other one being extremely maritime, stuck out here in the Pacific Ocean. So let's look at land-water heating differences. Once again, the main idea here, what I want you to be able to showcase to me is that you understand that in those places that are deep within a continent, what we call highly continental, or have high continentality, places like Mongolia, what's going to happen is the temperatures in the winter are going to get very, 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 very cold. But in the summertime, they're going to swing back and get quite warm. And so as you go farther inland, you get bigger swings in the temperature throughout the year. Now, why is that? That's because land heats up faster, but also cools down faster than water. And so being near a water body, being near the moderating influences of a water body, meanwhile, maritime locations, they don't have a big swing in the temperature. The winter temperatures don't get that cool. The summer, though, don't get super warm. For example, if you've been to Key West, Florida, pretty much every day of the year, it's like 80 degrees because it's stuck out there in the middle of the Caribbean Sea. Go over to Hawaii, spend some time in Maui. You'll sit there and you'll see every single day, it's like a high of 76 and a low of 72. It's like that every single day. And it's extremely maritime over here, stuck out in the middle of the Pacific Ocean. So with that being said, you should see evidence of this in your two countries. Maybe you have two countries that are both continental. Maybe you have two that are both maritime. But you should be able to see these patterns actually on the temperature map. So here in the case of Japan, once again, the main reason why we don't see much change from January to July, notice what we don't see, it's pretty much red throughout the entire country, is the fact it's extremely maritime. Not going to have huge swings. Whereas in Mongolia, we go back and forth and we see blue everywhere. And then in July, whoa, things change big time. Huge swings. In fact, this can be probably in this part of Mongolia, you're going to get temperatures warmer than most of Japan at the same time, because in July, during the hottest time of the year for Mongolia, land heats up faster, and so it's going to be brutally hot, especially in these more southern locations that are warm because of the role of latitude, because they're closer to the equator. Now let's use the Global Solar Atlas to discuss or identify the role of cloud coverage. And this is the best measurement I could find of kind of shows the average amount of incoming solar radiation that actually reaches the surface. And so this is the best way to do it, is the Global Solar Atlas given what we have here in ArcGIS Online. So what we'll do is we'll just go ahead and go to our two different countries once again that you're using in this example. Here once again is Mongolia. And so what this is saying is places that are orange, places that are red, they have a huge amount of solar intensity. What that really means is they don't have a lot of cloud cover. And so because of that, we associate in this global solar atlas places that are orange and red don't have much cloud cover. Whereas places that are in purple or gray or whatever this color might be, like Japan, they get a good amount of cloud cover. And so why does that play a role in temperature? We see the moderating influences of clouds. Clouds help to kind of keep the temperatures from getting too warm during the day, but also act like blankets and trapping the heat during the night. And so you have very consistent temperatures. Once again, this kind of relates to coastlines, but we're going to see more consistent temperatures where we have cloud cover. Whereas in the case of Mongolia, it has those situations where it has no clouds, and so during the day, it's screaming hot. The sun has nothing blocking it. It's the sun just coming ripping through the atmosphere. But then at night, nothing's acting like a blanket trapping in that heat. And so in Mongolia, you'll get temperatures that are extremely high during the day and then extremely low during the night. Where Japan, it's much more consistent throughout the day and night.